In this lesson, we're going to introduce you to a lot of new terms that are going to be used in geometry and also the correct notation that you need to use when referring to those terms. So we start with a point. A point, by definition, it doesn't have any thickness, it just holds a location. So if we look up here at this picture, we have point A, point B, point P, and point C. And the way we name a point is just with a capital letter. So if I want to name point A, I just put A. You don't have to put a dot in front of it, you don't have to put a word in front of it, it's just A. Next up we have a line. A line is a set of points that continues indefinitely in two directions. It's a two-dimensional shape. So a line could look like this. We have a picture of some lines up here at the top. Now a line contains at least 2 points. I'm going to put a couple of points on here. I could name this line, line AB. I could name it line BA. The symbol on top with the arrows going both ways, that's the symbol for a line, and it doesn't matter which letter you put first. I could also name a line with a lowercase cursive letter. So I could refer to this line also as line L. So 2 letters with the line on top of it, or just a lowercase cursive letter. A line segment is part of a line. It has endpoints. So to name a segment, let's say I could name segment CD. And a segment just has a bar with no arrows, and it doesn't matter which way we put the letters. It could be the segment that starts at C and ends at D, or starts at D and ends at C, like you have up here, if we just talk about this piece from C to D. A plane. A plane is a flat surface that continues indefinitely in all directions. So we'll focus on the fact that it's a flat surface, continues indefinitely. Since we can't draw something that continues indefinitely, we draw a plane usually as a parallelogram shape. And we'll say that's a plane. And we have to imagine that it continues on in all directions. Your desktop is a plane. The walls, the ceiling, the floor, those are all examples of planes. So in a picture, I might draw something that looks like this. And I'll label it similar to what we have up here. I have a C, a B, A, and notice there's a capital kind of italics cursive letter in the corner. That's going to be useful. The way we name a plane is by using 3 non-collinear points. Now you're saying, wait a minute, non-collinear, that's a new word. So look at the bottom of your page. For points to be collinear, that means they lie on the same line. So I'm going to take a look at this picture at the top. Points B, C, and A are collinear. They lie on the same line. Points B, D, and A do not lie on the same line. They kind of make a triangle. They are non-collinear. So collinear points lie on the same line. Non-collinear points do not lie on the same line. So one of the reasons we need to use 3 non-collinear points is so that it defines a specific plane. If I went up here and named a plane ABC, my plane could go many different directions. It could be this way, but it could also go up and down through the page, or it could go at any angle. So if we choose 3 points that make a triangle, 3 non-collinear points, we're going to name one specific plane. Another way to name a plane is to use this capital letter in the corner. So I could also call this plane P with the fancy cursive letter that was in the corner. So notice up here in this picture, P was not a point. It doesn't have a dot next to it. It was in the corner naming the plane. Just like this one right here, R is naming this vertical plane. Next up we have rays. A ray is a portion of a line. It has one end point, and then it continues in one direction indefinitely. So an example of a ray, back in this top picture, ray CD. Notice it starts at an end point, continues in one direction. So I'm going to say ray CD. I should have drawn that over here and given you the picture. Starts at C, goes through D, and keeps going. Now this one, it does matter what order you put the letters in. The end point has to go first, and then it goes through point D. And the symbol on top is always this arrow facing this direction, no matter which way your actual picture is facing. Now in this box, it also talks about opposite rays. So if we continue similar to the picture above, I just copied this picture, we have more rays in our picture. We have ray CB and ray CA. Notice they have the same endpoint, and ray CA goes this way, ray CB goes this way, and if I put them together, they make a line. So opposite rays have the same beginning point, and they make a line. Those are considered opposite rays. Another definition we have is an angle. An angle is formed by two intersecting rays. And you've probably seen angles before. So I'm going to take angle DCA. So notice ray CA and ray CD together form angle DCA. This letter in the middle of the three is always the vertex of the angle, or the point where they intersect. So I could call this angle DCA. I could also call it angle C, because in my picture there's no confusion about what angle C is. If you go up here, you could look at it, and if I said angle C, you might ask, well, do you mean this part of angle C, or do you mean this part of angle C? I would have to be very specific. This one is angle DCA or angle ACD. Notice the vertex stayed in the middle, but the letters could change. This angle over here is angle BCD or angle DCB. Again, C stays in the middle, and you trace DCB. So if there's no confusion about which angle we're talking about, you can just name it with the vertex. Otherwise, you have to use the three letters. There's one more thing we can do to simplify your life. Sometimes with your angle, right here in the corner, there's a number. So I could call this angle 1. And that helps me to avoid having to use angle DCA or angle ACD. If there's a little number inside of it, I could just call it angle 1. Now we have a couple of more terms down here, coplanar and non-coplanar. So I want to look at this three-dimensional box. Coplanar means the points lie on the same plane. So if I gave you a set of points like D, C, E, and F, or do they lie on the same plane? Well, they're all on the same side of the box, so I would say yes. Those are coplanar. So coplanar points lie on the same plane. Non-coplanar points do not lie on the same plane. Now remember when I told you how to name a plane, we said it took 3 non-collinear points. If I came up here and said, are points A, B, and D coplanar? You would always say yes, because that's 3 points, and 3 points make a plane. If I said are points A, B, D, and G coplanar, you would look at it and say, well, A, B, and D are at the top of the box, G is down here, those can't lie on the same plane. So those 4 points would be non-coplanar. One more term we have is the word skew. Now if you're looking at this picture, you would tell me, I think line DF, or segment DF, and segment CE, notice where they are, I think they're parallel. They're never going to touch each other. Then you could look at, say, BG and GF, and you would notice that if this was really a box, they would be perpendicular. They'd make a right angle. So they could be parallel or perpendicular. But what if I now went and asked you about segment BD and segment CE? Well, they're not parallel, but I don't think they're ever going to intersect, so those are called skew. Skew lines are not on the same plane, and they're never going to intersect. Okay, but they're not parallel, but they're never going to intersect. So when you're looking at skew, you're looking for something on the front of the box that goes sideways and on the back of the box that goes up and down. Or you could take one on the front of the box that goes up and down and on the back of the box that goes sideways. They're just never going to cross. A couple more things I want to mention. We have our planes up here in this picture. If I asked you, where does plane P intersect with plane R? Two planes intersect at a line. So if you notice, where does this plane intersect this one? Well, it's this line right here. I could call this BA, I could call it BD, I could call it AB, any of those. It's the line that contains A and B, which would also include the line that contains D. So you want to be sure if you are asked for the intersection of two planes that you list a line. Again, it could be AB, you could have said line BD, and so on. So these are some of your points, some of your definitions, and the correct notations you always want to use when referring to those particular definitions.